So today in this class, we are going to discuss about the decision table testing. Okay, a decision table testing is basically more popular than the those two techniques that we have discussed already, the boundary value testing and the equivalence class testing, because the coverage is wider. Those two techniques have some limitations. Say in case of the boundary value analysis, you need to have the boundary values which has to be some quantitative values. Okay, if they are non-quantitative, then it's difficult to find the boundaries. Okay, so those decision table is more widely used to make the complex business logic simpler. Okay, so the testing can be this for those test scenarios which requires to test the complex business logic. Decision table is more appropriate. So given some input conditions, we get the output. Okay, so we get a pictorial view with the decision table that what input condition gives to which output. So and this, because of this property, the decision table it may be very helpful, or definitely are very helpful in designing the test cases. Okay, because it helps the testers to determine the outputs for different combinations of input. Okay, what affects the different combination of input will give on the output, that can be determined. So definitely the test cases, it becomes more helpful in case of the test case designs. So in general, the decision table overall, the broad architecture, decision table is something, it looks like this. There are 4 parts in the table. Okay, the corner gives you the condition, that is called as the condition stub, where the conditions are specified for which is the different alternatives of the condition, not output, sorry. This is a different alternative of the conditions. So it is on the left hand top corner, you have the condition or condition stub, that all conditions are represented here with the use to determine a particular action. Okay, so all the actions are specified in the left upper corner, and different alternatives that apply. Okay, that is the values corresponding to these conditions. Okay, value entered here as the inputs actually for the conditions are given on the condition alternative on the right top corner. Okay, similarly, the left down corner are the action verbs or action stubs. Action stubs are the all possible actions are listed here given the conditions cited above. Okay, so for all those conditions, for whatever input that is being available on the right corner, that determines what action to be taken. So different alternative actions are specified in this left down corner, and then there is the right down corner here, the action entries, that is corresponding to the action, which action to be taken. Okay, so that is given in right down corner. So like here, the same thing that we have discussed in the previous slide can be shown this way, that is the condition stub. We are differentiating this with 4 different color combinations for better understanding of the concept. Okay, so the condition stub is given with the blue color, that gives you the C1, C2, C3 condition. Okay, the input entries for those conditions are normally taken as the binaries. Okay, in case of decision table, decision are all C, either in yes, no, or true, false, etc. So it is the condition entries for those conditions are cited. This is shown using the green color. Okay, so here it is the action stubs. These actions are different actions that can arise for different input combinations of those condition entries. Okay, so those actions, different actions are cited here as the 1, 2, 3, 4 that way, and this is shown with the red color to differentiate it. So for those actions, which actions needs to be taken, whether these or these. Okay, that is shown in on this side of the table, decision table, and that is shown with the brown color. Okay, so this is the action entries. Okay, now you can see there something written as the rule 1, rule 2, rule 3, 4, rule 5, rule 6, etc. So this rule, what does this rule means? Different combination of rules inputs, that is the condition entries, that gives you to these outputs. Those they can be, you can combine and pre-confirm the rules. That is, for writing the test cases, that becomes very helpful. So that is what actually, suppose it is like that. If condition C1 true and condition C2 is true and condition C3 is true, then the action should be either A1 or A2. So that becomes one rule. Okay. Similarly, in the rule 2, if condition C1 is true, if condition C2 is true, if condition is false, then action A1 or A3, okay, should be taken. Then action A1 or A3 should be taken. Similarly, for rule 3-4, if condition C1 is true and condition C2 is false, then action A4 should be taken. Okay. So here it is 3-4 because the C3 either does not matter, it is either true or false. So if it is, we can determine either for condition rule 3, suppose C3 is the true, then also it is false, A4 action should be taken, or if the C3 is false, because that does not matter whether condition C3 is true or false. Okay. So if you take true, that becomes one rule. If you take false, that becomes another rule. But for the action that needs to be taken is the same. Okay. So similarly, you can form all the rules here. Here is an example for the decision table. You can see it is for the printer troubleshooting. Okay. That is printer troubleshooting decision tree. So decision table, sorry. So it is the condition. See, with an example, it will be easier for you to understand. The condition here is the printer does not work, the red light is flashed, the printer is unrecognized. Okay. Now, if all these three are yes, that is printer does not print, yes, and printer, that means true, printer red light is flashed is yes, and printer unrecognized is yes, then the action that should be taken is these three. This one, this one, this one. Now what are those actions? Check the printer computer cable, or ensure printer software is installed, or check replaced ink. So any of these actions has to be any one of or more than one of these actions has to be taken to ensure that the conditions does not arise. Okay. So similarly, for the next rule you can see, if the printer does not print and red light is flashed and printer unrecognized is no, that is printer is recognized, that means. So for that condition, either check replace ink, right? These two conditions, these two actions, that check replace ink or check for paper jam. Okay, either of these two or both can be the cause of these conditions. Okay, so for printer troubleshooting decision table, we can have a decision table of this sort to identify what problem has actually, which gives you a very clear picture of how a decision table works. Okay, so it is like, see this condition, there is only one action here, so that corresponds to the printer is unrecognized, because that is the only true condition, yes condition there. Other above two are no. So for if the printer is unrecognized, then check replace ink. Okay. So this is, oh sorry, printer is unrecognized. This one, printer is unrecognized, is for this, ensure that printer software is installed. Okay. So that is the action for that. Similarly, for this, if the only true condition is, yes condition is, the red light is flashed. Okay. Red light is flashing. So for that, this one, right? So this is the check and replace ink. So this example is basically about the to find to solve the triangle problem. Okay, what is a triangle problem? Triangle problem is basically is that we take three inputs. Okay, three positive values, say some A, B, and C, and from those three positive three integer values, we identify whether a triangle can be formed or not. If a triangle can be formed using those three integers, then we have to identify whether what kind of triangle it is, whether it is a scalene, isosceles, or equilateral. Okay, so this is the problem. Okay, and then to identify the test cases for the triangle problem. Okay, so we can use the decision table to get those to solve this problem. So rule R1 for this triangle problem is that we have to take three integer numbers, positive integers, which are A, B, and C, suppose, and that are assumed to be the three sides of the triangle. Now, with these three values, we need to identify whether a triangle can be formed or not. That's the initial rule. Initial requirement. So that is the requirement number one. Requirement number two is that if the triangle can be formed with these three positive integers, then if the three values that are given the inputs here A, B, and C are equal, then it is a equilateral triangle. If any of the two sides are any of these two sides are equal, then it's isosceles. If none of these sides are equal to one another, then it is a scalene. Okay, so that is what the requirement number two to form this particular problem. Now, if both these requirements does not match, then a suitable error message should be displayed. Okay, so these are to design this particular these conditions for the test case design. We use the decision table. So in the decision table, we have 6 different conditions. Okay, given these three inputs. So 6 different conditions are C1, C2, C3, C4, C5, C6. Okay. So first condition is that a side which is represented by A should be less than B plus C. So whatever we get by adding B to C, the third should be less than that. Okay. So if this condition is true, then the triangle can be formed. Otherwise, triangle cannot be formed. If any of the side is more than or equal to the sum of the other two sides, then triangle cannot be formed. So if this condition is false, that is A is less than B plus C, then the triangle can be formed. Okay. Similarly, if B is less than A plus C, then also the triangle can be formed if this condition is true. But if that condition is false, then the triangle cannot be formed. That means if B is equal to A plus C or B is greater than A plus C, then triangle cannot be formed. Similarly, the third condition also in the same thing. That is, C should be less than A plus B. Okay. If all the three conditions are true, then only the triangle can be formed. Okay. So if C1 is true, C2 is true, and C3 is true, then we need to identify whether A is equal to B. If any of these is true, that is A equal to B, then it is isosceles triangle. Or if C5 is true, then it is isosceles. Or if C6 is true, then it is an isosceles triangle. Okay? And if all the three conditions are false, that means it is a scalene triangle. Okay? Or any of these two are true, that is A equal to B, the conditions C4 and C5 are true, but C6 is false. If all the three conditions are true, that means it is a equilateral triangle. Okay? So if all the three conditions are false, C4, C5, C6 is a scaling. If all the three are true, then it is equilateral. And if any one of is true, another, suppose if A is equal to B, okay, then it is a isosceles. So first three conditions is C1, C2, C3 are basically for the requirement number 1 that we have discussed in the previous slide. And the next three are to determine in the requirement number 2, given the first three conditions are true. Okay. So here is the algorithm for that. The step 1 is that you need to take all the three positive integers as the inputs. Okay. Then in the step 2, you identify whether the triangle can be formed. That is by checking that condition if A is less than B plus C. If all these three conditions are true, because they are C, there is n in between, so all the three conditions has to be true. Okay, that is, then we can go to step number 3. Otherwise, you go to step number 6, which is nothing but stop. Okay, so if all these three conditions are true, then we go to the step number 3. Now, in the step number 3, we check for equilateral condition. That is, if any of these two conditions are true, so it forms the equilateral triangle. So if A equal to B and B equal to C, means it is the equilateral triangle, and so it is the then you identify that it's equilateral triangle and go to step number 6. If the next condition is if we have any of these conditions, any one of the single conditions are true, that is A equal to B, or see there are or in between, so A equal to C or B equal to C, any of these two sides are equal, that means isosceles triangle. Otherwise, if both these are false, there is all the sides are not equal to each other, any side is not equal to any other sides, in that case we print this particular triangle as the scalene one. Okay, so this is a very simple algorithm for generating the test cases for the triangle problem, and this is how the decision table is formed, that we'll see in the next table here. This is the decision table. Okay, that is, those conditions, those 6 conditions are specified in the condition stub. So these 6 conditions, C1, C2, C3, C4, C5, C6. Okay, these are in the condition stub. As I was telling you now, that the first 3 conditions, C1, C2, C3, they refers to the requirement number 1. Those conditions has to be true to go for the condition 4, 5, and 6. So for C1, C2, C3, that is, if it is, you can see the rule number 1, and these are the actions given the conditions. What actions? Action A1 is not a triangle. Action A2 is a triangle is scalene. Action A3 is the triangle is isosceles. Action A4 is the triangle is equilateral. Okay. So, and action A5 is it is impossible. Okay. So you see here, is impossible means, that is like the condition A4, A5, A6, the combination that is given cannot arise actually. That shows the impossibility. That is not possible there. Okay. So that comes in the category of impossible. We'll come to it. But first thing is that you see this one, the rule R1, that is the first condition C1 is false. So if that particular condition C1 is false, that means we don't have to check any other condition. It is not required. That's why the below, in the vertical line you see below R1, the other condition values are empty. Why it is empty? Because the first condition is enough to determine the action that it is not a triangle. Okay. Similarly, for the R2, rule 2, you see, the condition B is less than A plus C is false. So the below the other conditions are not required to be checked, and you can determine that it is not a triangle. Similarly, for the rule R3, you see the third condition is also the same thing. After that, you need not check if this is false. Okay. If all these three conditions are true, that is three conditions you see T, T, T in the rule R4, all the three conditions are true, then you go for condition C4. Okay. So all these A equal to B, A equal to C, and B equal to C. So it is a equilateral triangle. Okay. So action step determines here it is equilateral triangle. Now, rule 5 you see in the actually in C4, C5, C6 we are considering all the possibilities here. All means all different combinations, possible combinations of true and false. Okay. So here you see in rule 5 you get after these three conditions are true, there is true, true, and false. So if the condition C4 is true, that is A equal to B, and if the condition C5 is true, that is A equal to C, okay, A equal to C, then B has to be equal to C. It cannot be that B is not equal to C. So that is why it is given as the impossible. Similar is the case here. If the condition C4 and C6 are true, then C5 has to be true. Okay, since it is false, so it is impossible. Okay, so there are three impossible conditions. Similarly here also. But R4, the rule 7, what the rule 7 says, that is the first condition A equal to B is true, but the that is the C4 condition is true because the above three are anyway true. Because in all these cases, starting from rule 4 to rule 11, they has to be true because then only the below condition, three conditions can be checked for the requirement 2, right? So it is in this case for the rule 7, it is the when we say the C4 condition is true and C5 and C6 are false, that means the triangle is isosceles. Okay, this is the isosceles. Similarly, rule 9 you see, in the rule 9, if it is the condition C5 is true but C4 and 6 are false, then it is isosceles. Similarly, in the rule 10, you see the condition C6 is true but C4 and C5 are false, so it is an isosceles. Okay, and in the rule 11, what is the rule 11? Is that those three, all these three, C4, C5, and C6 are false. That means none of the sides are equal to each other. So the scaling, that is the A2 condition is true. Okay, A2 condition applies. So this is the decision table that determines the triangle problem. Now how to form the test cases out of this decision table. So these are the test cases. We take different values for those three input data A, B, and C. Okay, we can give a missing input for some values, the three values as you can see here. The test case, you see every test case has a test case ID, which is the leftmost side. Then test case description, what test case it is, that has to be described. Input data, which you are giving as the input for the variables in test cases. Expected output, what is expected of that particular of the software, that is the expected output, and what you actually get. Okay, so now every success of the test case is determined by seeing these two columns, the expected output and the actual output. If both of those matches, then it is a success. Okay, so status becomes the success. Now, in this case, say for A input, if A input is not given, you see A input is not given. So if A's input is not given means it is 0, right? In that case, the condition will be false. That condition that we have described earlier, it will be false, and therefore it cannot be a triangle. So expected output is not a triangle, and the actual output is also not a triangle. Similarly, so for all these three cases, first three test cases, we have intentionally remove one of the values. We have not put one value. So if you do not put one value, then the condition is bound to be this condition is bound to be false. The C1, C2, or C3, any of these. So When this condition is becomes false, means the triangle cannot be formed. So it's not a triangle, not a triangle, and the status is success because both the expected output and the actual output matches in the test cases. Okay. Similarly, C4, that is the suppose one input is negative. So when you give a negative input, same thing applies, and so it is not a triangle. So success. Two sides are same. If the two sides are same, then you should get a isosceles. Expected output is isosceles. As from the decision table, you can see if the two sides, which two sides have been given as equal here, A and B. So when A and B are equal, that means it is the C4 rule satisfies. Okay. So that C4 rule satisfies means it is only where the C4 is true. That is the rule number 9. Oh, rule number 7, right? It is the where C4 is true and C5, C6 false. Okay. So that gives you the outcome, that is the action as the A3, as you can see. Okay. So that is isosceles, right? So similarly, when you give the A and C as the same value, then also you should get isosceles. So expected output and the actual output are isosceles. So the test case result is success. Similarly, for the test case ID 7, you give B and C as the same value, so it becomes isosceles. Again, this is a success. So if all the sides are not equal, you can put different values, A, 1, 2, and 3, and you get the scaling. Right? This, the scaling is true is R11, right? So where you have all the C4, C5, C6 as the false. Okay. So it is, and similarly again to check whether it is, if it is a not a triangle case, you can put one value very large, which is greater than the sum of other two values. So that will make the condition in the decision table false. This either C1, C2, or C3 false, or C3 true, right? Okay. So it is the this one, any of this condition false. Sorry, if any of this condition is false, if suppose A1 is abnormally high, that is, see here, the A is given as 10 in the test case number 9. A is given as 10 and B and C as 2 and 3, right? So 2 plus 3 is 5, which is less than 10. Actually, 10 should have A should have been less than B plus C, but that is false, right? So since this condition is false, so from the decision table we can determine that it's not a triangle. Okay. Similarly, B is less than AC. So that should be true for the triangle, but here B is very large and B is greater than A plus C. So that condition is false. So from the decision table we can determine that it's not a triangle. The expected output is also not a triangle, so the test case is success. Similarly for the C, okay. And now if all the sides are equal, 5, 5, 5, that means what? That the C4, C5, C6 are true, right? That means this is a equilateral triangle. So if you can see the C4, C5, C6 it is the R4, right? Which determines the equilateral triangle. That is, C4 is true, C5 is true, and C6 is true. Okay, so it becomes an equilateral triangle. So thank you. This is how addition tables are created to generate the test cases, and it gives a very simplified version of the complex logical problems. Okay, so for many complex logical problems, the decision table becomes a handy tool to determine, or you can say to determine the outcomes and also to generate the test cases.